Christina. And yeah, it's really a pleasure to be here, and thanks a lot for coming. And so, well, we're going to ask that weird question, because science is not supposed to be something you have to believe in. There was a famous tweet of Neil deGrasse Tyson that said that the good thing with science is whether you believe it or not, it's true. And while it's a valid objective, a valid goal for a scientific method, and that it's true that science can unravel patterns that are so repetitive that you can consider them as universal laws that are going to repeat themselves and therefore are true, we need not to forget that science only creates relative knowledge because it's made by us that are subjective beings. And it's false and limiting to say that everything that is produced by science is true by essence. And it poses a question that is the acceptance of a scientific fact as true or not, and that is belief. Belief is accepting something as true or not. And well, there are some scientific facts that are not laws, that are not absolute, and that can be put in question. And to deny that fact is super limiting to science, for scientific research, because the thing science does is just, it answers a question not by yes or no, but by maybe, with a certain degree of probability, and that has not to be forgotten. Otherwise, you put in question the capacity of science to question itself, and that's the main principle of it. It's supposed to be able to doubt, and it's the systematic doubt that makes science such a great method. And so, through my career, I would say, because I'm still a student after 12 years, I've studied medicine for 6 years, and I've been taught all of these models, all of these great theories. And when you start practicing, you realize that, well, most of your job is not applying the theories, it's questioning them. And it's applying them in a way that is not standard. You almost never use the things as they are in the book, and sometimes your work is even to question if you're going to use the model or not, if you're going to use the technique or not. So that gives a super interesting perspective to pass from that theory to that practice, and to realize that even if there's beautiful theories that are supposed to work all the time in the real life, it's not always the case. And the same goes for science, because I've done a Master of Science, and when you study science, you're taught all of these beautiful methods and all of these reproducible techniques. But when you go into the lab, you realize that science is made by humans, and humans have a shitload of bias. They have defaults. They are subjective. And so even if they wield something that is objective, if you wield something objective as a subject, well, everything becomes subjective. And so that was also an interesting point of view on how that tool of science is made. And so we're going to go through 3 different chapters. So we're going to define the terms of knowledge, science, and religion. So we are talking on common basis. And then I'm going to try to demonstrate that in every scientific research there's the role of belief, there's a role for acceptance, and that a scientific fact has to be accepted or not by the community, and that not all of what science produces is laws, and in fact nothing of it is laws. There are just degrees of certitude, and that's why the role of acceptance and belief is so important. And I'm going to talk about the fact that we as subjects, we as society, impact a lot science, the way we do it, because we ask it the question. We can only ask the question we ask it. It doesn't ask any question. We are the one asking the questions. We are the one using the tool. And we have a great impact on how science is used, and in the same way, science has a great impact on our views of the world. The rise of the scientific method has had a super important impact on our society. And so we're going to start by defining what knowledge is. So we're going to start super early in evolution, because I think that life is defined by its capacity to react to its environment, to offer, to present complex reactions to a stimulus that comes from the outside. And that's what shapes species, that's what shapes evolution, because if there is something that kills you, that touches you, and you are able to avoid it, you are going to logically survive more than the one that is not able to escape it. And in the same way, if you're able to go grab something that is positive, that is positive for you, you're going to survive more. And so that capacity to react in a complex and reproducible way to the environment really shapes the living. And it's something that comes really early in evolution, and that is present in every kind of cellular cellular organization, because we see that bacteria, that is a prokaryote, is trying to escape that neutrophil, that is a eukaryotic cell. And you see that the capacity of that bacteria to escape that neutrophil is going to determine the survival of these two things, because if the bacteria escapes, it's going to kill the host. But if the host manages to eliminate the bacteria, well, the bacteria loses and gets selected. So that capacity of reacting to the exterior world, it really shapes the living. And you see it's present in every single brain, and that's in every part of the living. That ability to react in an adapted way to the environment is going to take different complex forms that are going to allow all of the species to thrive or not, depending on if it is adapted to their environment or not. And a further refinement of that capacity to react is the capacity to acquire knowledge, is the capacity to, during your life, learn that a stimulus can be negative or positive to you. And that is a great advantage, because you don't have, before that, if you are not adapted, well, you just die. But with a species that is capable of learning, well, you can learn something, find that it's negative for you, find that it's negative for you, and you see these cats, they make the link. They have made the link during their life, while they were alive, and there is no need for new generations to come and acquire these things. And so that's a great refinement of knowledge, is that capacity of learning during your life. And so these cats make observation. You give me food, and it's when I push the button, so they make a link between things. But you can make more complex observations and make more complex hypotheses. And so the example I'm going to take for there is like, imagine a tribe of prehistoric men trying to follow a herd of reindeers, for example. So they know that these reindeers have been spotted in these 4 points, and what they want to do is find the reindeers, and if they do so, well, they will have meat, leather, and all what goes with reindeers, and so it will give them power to survive, and it will give them ability to go further. And so it's really important and really strategic that you are able to make these observations, these hypotheses, and this conclusion in the right way, otherwise you die. And so what is going to happen is you make a hypothesis, and then other spottings are going to occur. Some of them are going to confirm your hypothesis, and some of them are going to be outside of it. And out of that, you're going to shape a theory. And that's the further refinement, because you're able to learn during your life, but even better, you're able to transmit what you've learned to your species. And so you're going to enable everyone in your tribe, in your species, in your whatever, to survive, and they don't have to be confronted to the problem, because you have already told them what it is. And so you need to transmit that information, and in human species it also comes often with Why? Because you need to explain people. It's like wet paint, you know. If you just put wet paint, people are going to touch it all the time, and so you have to. It works better if you tell people that if you touch wet paint, you're going to be struck by lightning. Well, they're really not going to touch wet paint after that. So that theory has to be accompanied with an explanation to be adopted in a large manner. And so this is a cyclical process, because the events you observed are going to become observation, and then you're going to refine your model, and new events are going to come, and you're going to reform your model as time goes, and it's going to allow you to adapt yourself to your environment and to the different observations you're going to make. And so, how does religion, how in society that are dominated by religion, how does this work? Well, the main thing that religion manages is the question it asks, because they are going to make the hypothesis of, they're going to ask, well, I want to know where the reindeer is going, because if you never ask the question, you're never going to have the answer. So the religion is going to ask a question that is relevant to its environment and its ideological corpus, and it's going to transmit a theory that is also that has to fit with their corpus and their ideology. But we often think as religion as something super crippling, backward, ignorant. But they have integrated a lot of super important things that have tried to survival. Even if Egyptians had magical thoughts and the doctors were priests, they were able to do complicated eye surgery, remove cataract, and they were able to treat complicated diseases. In the same way, there is the example of these Middle Eastern religion that have forbidden the consumption of pork meat, because these regions have a high prevalence of the tapeworm. And so they did not know about the tapeworm. They did not know. They thought it was a malediction or whatever. I don't know. But they still had an adapted reaction to that thing.
If that was actually the explanation for why Judaism doesn't forbid pork, shouldn't you see all of the other religions in the region also forbidding that?
Sorry?
Shouldn't you also see all the other religions in the region also forbidding that?
Yes, but
you don't.
No, sorry?
Islam does.
Islam does, and also Judaism does, and that's of course they don't do it all, but it shows you that a religion are able to incorporate in their corpus of ideas something that is going to shape the survival of their members, because they're going to give you rules that allow you to thrive more.
So by that evolutionary argument, shouldn't Judaism have taken over the entire region because all of the other core religions in that region?
It's not a question of. It's not a question of, because it's not only shaped by that, and there is a lot of other determinants. The point I'm trying to make is that they're able to incorporate these informations to their corpus, their ideological corpus. It's the ability to incorporate inside of their ideology something that is indeed useful, that I want to point. Not that it's going to make them completely take over the world because they're way more intelligent than the others. It's just that, well, they're able to do that. They're able to incorporate that. And so there's also the example of monogamy in Christianity, where one fourth of European population had syphilis. It only makes sense to tell people to have only one partner when syphilis was a pretty bad disease at some point, because it was something that is going to kill your entire family.
wasn't monogamy part of religion long before syphilis? Syphilis only came in 1492.
Of course, but it's the case. It's the case for a lot of other sexual transmittable diseases. There's not only syphilis, but syphilis was something that was absolutely devastating, and so that's something that made sense. The thing that I want to point is that they are able to implement something that makes sense, and all of the traditions are not coming out of nowhere, and they are an adaptation to the environment, and they're capable to incorporate these ideas in a way in order to make their population thrive, wrong or right, because sometimes it's a possibility that you're taking a good decision or a wrong decision, and that your environment is going to change, and that the good decision is going to become a wrong one. I'm not finalist. I don't say that these things were taken, these decisions were taken because they make absolute sense. They were taken because the point I want to make is that it's possible to take these things that shape evolution and put them into a corpus of idea and transmit them through it. That's the point I want to make. And so, what science does, it's going to take out of the nature. You're going to alleviate yourself of the necessity of observing things in the nature, because you're going to try to reproduce what you're seeing, the phenomena that you're seeing in the nature, in a standardized condition, and you're going to try to reproduce exactly the phenomenon you want to study. And the main difference is that by doing that, you're going to be able to make way more data points. You're going to be able to make more observation, because you don't need to wait for them to happen in the nature. You don't need to wait for it to happen, because you can reproduce it inside of your lab. And so I'm going to be able with that data. If I'm one of the hunters of the tribe, I'm going to be like, dude, I don't care what your God says. I'm not going down there. There's no way I find any reindeers here. I'm going to take the other trajectory. And that is something that is going to be backed up by all that evidence you're going to be able to give. And science is that tool that allows you to gain resolution on the problem you want to address. Because the thing you want to address is the truth, for example, the trajectory of the reindeer, that is an intellectual object. It's not something that you can really determine, because it's something that is fuzzy, and you can only have points of view from this thing. You can never break it down to something real, because you're only able to do observation, punctual observation. But if you make enough, and here you see it's a very simple object. You have the square, you have the round, so it's pretty easy to deduce that the object that you're going to observe is a cylinder. But and so that's a way of multiplying the observation in standardized condition and with more resolution, and to multiply the point of view to better determine the object of your interest is the scientific method. And the science is the way data that is obtained by the scientific method is transmitted throughout the different members of the society. But this is a fundamentally reductionist approach, because that is absolutely not the trajectory of a reindeer. It's a bunch of points on a whiteboard, and that does not really depict the situation that you want to depict, because the only thing that depicts that situation is the actual reality, but that you don't have access to, because you are limited to the perception you have of it. And so, because you are reductionist and you cannot take every single parameter into account, because if you want to predict exactly the trajectory of these reindeers after seasons and seasons, you need to know the weather, you need to know how the predators behave, you need to know a shitload of things. And so there is, of course, a limit to the quantities of things you can implement into your model, of the quantity of things that you can take into account, because you are not able to take into account all of the nature. So you have to be limited, and there are things that are going to happen that don't fall into your model. Of course, at some point, even if my model is super well done, I'm going to see a deer in a place where it's not supposed to be. And it's not a biggie. I mean, if it's only one, does it really contradict my theory? No. I mean, if I have that data, I think it's a super good idea to follow that path. And even if there's one outside, that does not contradict the fact that it's better to do it, and that is a valid theory. But imagine that the more systems are complex, the more factors you have to take into account to make predictions. And because of that, the incertitude is going to grow proportionally to the complexity of your system. Because let's take, well, that example I just took. If you really want to predict it in a perfect way, in a way that it's valid, you're going to have to take a lot of parameters into account, and the more your system is complicated, the more parameters you have to take into account. And because you cannot, there's more and more things that are going to go outside of your prediction. And that point is what we call odds. That is a fluke. That is hazard. That is something that is luck. And that is something that you have to address, because it's questions the validity of your model. Is your uncertainty acceptable or not? That is a big question. And that was really fun when I was preparing that talk, is that people who have a specialty that address somehow simple systems like astrophysics or geology, they're like, oh dude, you cannot question that, that's going to be another flat earth talk, and there's no way you can question the validity of these experiments. And in the other hand, people who address complex systems like psychologists, psychiatrists, doctors are like, go tell them that the models are not representing the reality, because it's true, the more complex the systems are, the more limited your models are to represent what is going to happen in the future. And because because we only can gather relative data, all of our models are biased and strong. Of course, the proposition the sun is going to rise tomorrow is going to be false at some point. It's something that has almost zero probability to happen, so I can neglect that and consider that the fact that the sun is going to set tomorrow is a law. I don't really need to question that, because the probability that it doesn't is neglectable. But if you're in a more complex system, can you trust blindly your model? So I'm going to take an example. I was in the ER and I received a patient that had a belly ache. And so she told me she had a fever and she was not feeling good and all. And the nurse took all of the vitals and everything was perfectly normal. No tension was good, heart rate was good, no problem. We did a biological sample. Everything in the biological sample was perfectly normal. So at that moment, if I had taken my articles and looked, oh, okay, what is the probability of someone that has normal vitals, that has normal biological parameter, to really have a serious problem? Well, I would have found a result that is super low. I don't know, maybe less than 1%. But when I interrogated her, I found her, tired. Her family was saying she's not at all like she uses to, and her belly was not really like what we call a surgical belly. It's not like super hard, but I did not know, and so of that, I got that feeling, that hinge that I was just not feeling it. And so when you call the radiologist to ask your scanner, he tells you, yo, dude, there is absolutely no probability that that patient has a serious problem. Look at it. She has the exact the exact good vitals. She has the exact good biology. So look at our model. So he confronts to me the model, and he tells me there's almost 0% chance of that being something serious. But because in medicine you learn that it's not about applying the models, we still pass her in the scanner, and her bowel was bursting open. She had a huge appendix that had just not provoked the symptoms we were waiting for, and 2 hours later she was in a septic shock. And so in that case you can see that our models could not be trusted, and in fact they were they were setting us in a wrong direction. And so that asks the question of the trust in your model, and the fact that the thing that makes the difference between reasonable trust and faith, between a law and a clue, is the human. And so it shows the importance of, yes, making models that are more and more performant, that are able to predict more and more things with more and more accuracy. But in the end, the applier, the person that applies the model, is super important, because of course you have to have a great tool, but you have to know how to use it too. You have to know its limits. And that's something that is really important to take into account, because if you blindly rely on your models, you're going to do shit all the time. And so it's really important that there's people that are able to analyze that frontier that is fuzzy between something that is usable, that is a law, like sun is going to rise tomorrow, and something that is not, like the model I just told you about. And so because of that, there is an absolute need for consensus, for people to examine the data and to wield that data alongside with all other specialties, because in the story I just told you, you see that a lot of things were implied. It was intuition, psychology, empirism, because it comes when you have touched 1,000 bellies to know that that one is weird. And so it involves a lot of things, and science is just a part of the reasoning. It's not all of it. It's something that you have to put in perspective and contextualize a lot in these complex systems such as the human body. And so there is an essential need to validate. And you'll tell me, well, you just need to make a better model. You just need to put more data, and at some point you're going to have something that is sufficiently good to withdraw the need from the human. But the thing is, it is really hard to do. It's a really hard problem, and these models have, because they're reductionist, because they don't take everything into account by definition, they are limited. And if you don't take all the parameters that are going to influence your model into account, which is determining the future, the present, you're not going to be able to accurately determine the future. But you tell me, well, you just need to compute more. But look, the theory of chaos is an interesting thing, because look, for example, at this simple system. So I'm going to make a close approximation. So I have reality. I input in my computer the equation of a pendulum, and on my model I'm going to input that equation with a slight approximation. And I'm going to see if my model is able to predict reality. And of course they're super close, and it's a simple system, so they're going to follow each other, and I'm going to be great. My model works all the time, that's super. But let's take a little bit more complex system, and that is a double pendulum. And so the red one is reality, what you want to predict. The second thing is the model that is close to the 10th decimal, and The third model is the one that is even closer, that is close to reality, to the 20th decimal. And so you're going to see that in the beginning, your predictions are right. They predict reality, they follow each other because the equations are really similar to each other, because you have been able to determine the condition, the initial condition very precisely. But the one that is the more approximate at some point is going to do something that you cannot predict. And at some point, the other one is also going to do something that is completely chaotic. So that tells you two things. It tells you that the level of approximation of your system, the precision in which you're able to go into the decimals and you're able to precise every single factor that is going to play a role into determining the future is important, because the more approximation you make, the more chaos you'll have, the more flux you'll have, the more improvisions you will have, and the more crazy things are going to happen that are not planned in your model. And it tells you a second thing is that before you see the reality happen, you don't know if your model works, and you don't know where it's going to go. And so you have to confront your model to reality. You have to put it into experience. You have to put it in the real life, and you have to wait for the phenomena to exist. For example, for a disease like cancer that takes 30 years to appear, well, if you have a model that predicts cancer, you'll have to test it on 30 years to see what are the risk factors, what are the factors that influence, before you have tested your model in a population that is going to, and that reality happens. You're not able to say if your model is right or not, and at what point is going to be right or not. So you see that there's a big incertitude in every knowledge that is produced by the scientific method. And it says, that's why I said it says always maybe, with a certain degree of certitude. So how do you determine that degree of certitude? How do you say, I can believe in that or not? Statistics are supposed to play that role. Statistics are going to say, okay, that conclusion you've drawn has that chance to be wrong, that chance, there's that type of chance that something goes out of your model. But statistics are something that are completely subjective, and as it says on that mug, it's the only science where two recognized experts with the same set of data can give you a completely opposite conclusion, because there's a lot of things that are subjective. What equation you're going to use, what is the p-value you're going to use? There's no consensus. P-value is something that is that has just been decided arbitrarily. And I've been working in 3 different specialties, in respiratory physiology, in microbiology, and in clinical and in immunology. And the p-value is the same for these 3 models, and it's never put in question because, well, it's recognized as okay, but it's something that is completely subjective. So there is a lot of subjectivity in that interpretation, and in that degree of confidence you allow to a model. But it's not over with subjectivity, because as we say, science is made by scientists, and we rely on imperfect senses. So when you're reading numbers in a capture, that's okay. Well, you're just putting the numbers in. But when you're asked to evaluate the pain of somebody, what are you going to rely on? You're going to rely on super subjective things, and the way you're going to input your data is entirely subjective. It depends on the person you're talking to, it depends on yourself. And so we thrive to get more and more discrete and more objective data, but for things that are complex like pain, you can never get something that is really substantially objective. So you have to rely on these imperfect senses, and there's a lot of subjectivity on that. There's also a lot of personal know-how, because when you're in your lab, you're doing your experiments and all, and you're publishing a paper. But if you forget to tell something that is important. Well, your experiment is no more reproducible, but you tell me, well, it's not that complicated, just describe exactly what you're doing and there's going to be no problem. But there are so many factors that can play. For example, I've been trying to reproduce an experiment for 1 month and I could not get the same results than my colleague. I was doing it over and over and over again, and I realized that she was it was bacterial culture, that she was just unscrewing the cap of half a turn more than what I did. And so her culture had more oxygen than mine. And so that was the reason why our experiments were so different. And you see how such little factors can play a huge role, because we were testing these things into rabbits, and the difference was my rabbits never died because I did not have bacteria, and her died all the time. So it's super different, and it's uncapping the screw for of half a turn. So that is something that is almost impossible to objectivize perfectly. And of course, there's also the fact that there's pressure to publish. And I mean, when you're a PhD, everybody that works into research knows that it's publish or perish. And you know that journals want to publish positive articles, they want to publish things that look fancy. So you're only a human being. You want to keep your job, you want to keep your security. And so even involuntarily, you're going to want to produce a data that is more publishable, and you're going to tend to publish things that are to produce a data that is more suitable for the publication. And of course, there's conflicts of interest, and that I'm not going to talk about. It's obvious that when you're a PhD that earns 3Ks a month, you can be corrupted by a company that has billions to dispatch into lobbying, and that's not something I'm even going to discuss. But you're going to say, oh, that can be controlled. You just have to monitor people. I've been working on 3 different studies, and at no point somebody came over my shoulder to look at the way I was putting data on my Excel file. And so when you read my paper, you have to believe that I'm an honest person, and I was not bullshitting, and I was not trying to go away with the thing, because you have to imagine that most of medical clinical research is made by residents that have worked 100 hours a week and that come out of a night shift and are like going in the dusty archives to put the data on. And that you believe that these people are not going to make a mistake, that they are not going to be like, I don't find that data, fuck it, I'm going to put something that I don't know. Or be fully dishonest, being like, okay, I want my paper to be published, otherwise I'm not going to get that job I want. Yeah, I think that patient has the disease I want to study, of course. So when you read a paper, you trust on all of that, and all of that is a source of subjectivity, is a source of aleatory things, it's a source of randomness that you have to take into account. It's normal that it happens. It's normal, science is made by humans, there is no problem with that, but you have to be aware of that. And that's why one paper is not a relevant information, it has to be tried a lot of time, it has to go through trial and error. And if you fail to evaluate correctly the degree of confidence you can put in that paper, that is through all the factors that we've seen before, the science, the subjective scientists, the subjective statistics, all of that, and if you don't see through that, and if you are not aware of that, you're going to take for truth, and you're going to rely on facts that are not. And that is super dangerous, because you're going to build something on air, and when you're going to discover that the first paper you read was false, it would be too late. You will have constructed all of that theory on nothing, and everything is going to crumble. So it's really important to to get that scientific data is absolutely not objective, the way it is produced. And so the tool is not that objective we see now. But there's also the fact that we saw that science only says maybe to the question you ask it. But which question do you ask it? Because it does not make the question. It doesn't tell you what is relevant to ask. And who asks the question? It's individuals, it's society. And it is done in a cultural context, in an ethopoetic, in an ethopoetic way, in the narrative you have of your culture, of your civilization, etc., and on your history. And for example, it's interesting to analyze that science is written in English with a lot of Greek and Latin words, which is a big barrier because we know that a lot go through language. That there's a lot that goes through the representation of the world, and for that, science is not universal because it uses a peculiar language, it uses a peculiar cultural subset that it evolves from. And it's interesting to analyze through history that, well, in religious domain society, well, religion were preponderant. That is an interesting thing because the left one is the king and the right one is the god, and you see that they have the exact same attributes. It's two different paintings that have been painted 200 years apart, but you see that the king and the god have the exact same attributes, and that the king takes its legitimacy in the fact that it is the garant of the power of God, and if you and at that point humans were submitted to this power. When something was happening, people were telling you, well, that is because of divine things that made that happen, but the scientific revolution and the thing that we call the Cartesian moment has been the moment where humans have discovered that, well, the things that are happening to us are not the fact of God, they are the fact of the determinism of the universe. There are things that we can predict in a way more accurate pattern, and we don't need to be the victims of the God, we don't need to be the victims of the king anymore, and it's no coincidence that when the religious doctrine had been efficiently questioned by the scientific method, that the monarchies that were taking their power from their divine power fell in the same time. And so that Cartesian moment is interesting because it puts us in a weird situation where we are able to see through things, we are able to see natural laws, and we are able to see the determinism of the universe. And it gives you a vision of the world that is really peculiar. It gives you a deterministic vision of the world. And there's a few symptoms of that in the history, because I'm sorry. The thing is, so humans have become central, but it's not really humans that have become central. It's their capacity to see through things, to see things in an objective manner that does not depend from them. But we've seen that they are not really objective, and if it's true that there are patterns that resemble to law, there's a limit to these laws you can determine. And there has been a few historical symptoms of that conviction that all of the laws of the universe could be determined. For example, Kelvin in 1900 held a conference where he said, well, physics is all figured out. We figured out most of everything. The only two things we haven't figured out is how the ether works, the void, and how in thermodynamics, why the radiation of black holes are in certain the situation becomes infinite, so there was a problem with that calculation. And then he said, oh, that's the only two clouds in the blue sky of our comprehension of the world. And behind these two clouds were just relativity and quantum physics. So you see that there was that conviction that we could determine all of the world through natural laws. And there's also another example is the atom. The atom is a really fun thing because atom means that you cannot break. A is the privative and Thomas is to break. And so Dalton, in the end of the 19th century, thought that he had found the brick of the universe, the fundamental matter that made universe, and the billiard ball that was going to bang other billiard balls and create a succession of action that you will be able to predict. But in fact, now we realize that there is no such thing as an elemental particle. We realize that there is no such brick that you can follow in a deterministic way. So that illusion of being able to see through things in a perfectly objective manner has had immense impact on the way we see the world, because we were thinking that we were able to see through occurrences and go out of the cave, and that we are able to see what are the real objects, see what is the real world. When you see with these examples of Dalton and of Kelvin that these little clouds, these little steps we had to climb, well, they were holding infinite complexity, again infinite complexity, and that in science every time you climb a step you discover an entire new floor. So are you ever really out of the cave? Are you really ever able to distinguish reality on that way? To me, the answer is no, because the complexity of things is infinite. And even if you can determine with precision the interaction of the bricks that make the universe, well, you are not able, it doesn't necessarily mean that you're going to be able to predict accurately the emerging properties that are going to go out of these. And so that conviction of being out of the cave has had immense sociological and civilizational implication. It's the thing that explains that scientists thought that they had a better view of the world. They thought that they had a real view of the world, when they were not approaching that real view, because if you consider your models and reality as two curves, and you consider that reality is an asymptote to your models, they're never going to be together. You will never be able to see the real things. So is it really better to be a little bit closer to reality if you're infinitely far from it? That has to be discussed. There is no really better on it, because, well, everything that is alive right now is at the summit of its evolution. Everything, every animal, every person that is alive is at the summit of the evolution. You cannot quantify evolution in good or bad. That's not something you can do. You can classify things in terms of more simple, more complex, but you cannot say that one is better than the other. You cannot say that bacteria are worse or less. They're just more simple. But how are you going to quantify that evolution? Are you going to say the mass of DNA? Are you going to consider the capacity to survive? Well, if you consider that, well, science is not winning at all, because, well, I looked to the news recently, and it seems that it's not really capable of preventing the problems that are happening. So that conviction that the scientific view of the world is better than other views of the world is false. It's just an other view of the world. It's an interesting view. It's a super interesting tool. but you have to remember that it's as imperfect as the other visions of the world. And I forgot my citation in my book, but Mono, the guy that discovered the messenger RNA, allow me, I don't know, well, no, don't bother, I'll read it afterwards. But he was saying that by atomizing reality that much, science is getting further and further away from it, and that it's not giving answers. And the only thing that it has that is better is that is giving us power. But power is not per se good or bad, it's just power. There's no way you can consider that the power science gives you is good or bad. So you have to consider that it's a method that is as imperfect as the others, and also that it only answers the question you ask it. And so if you ask the wrong question, you're going to have the wrong answer. While it is true that my model, if I include that model, I said that I see a round thing there, I see a round thing there, so in the middle shall be a sphere. You can completely neglect the complexity of the sphere you're seeing because, yeah, Earth is a sphere, but it's more than that. And if you ask the wrong question, if you use a tool of wrong resolution, you're going to miss a lot of things. And a good example for that is food, because it's true that if you increase the number of calories you take, you're going to get fat. That is true. But if you focus only on that, you're missing the whole point that food is a lot more than just a calorie intake. It's sociology, it's rhythm, it's a molecular biology and chemistry of infinite complexity that has been refined through ages and ages and ages. And when you try to atomize food into macronutrients, you're completely missing that point, and you're completely missing all of that beautiful evolution, all of that contract that has been passed with nature during all of these years. So it's dangerous to think that something that has not been seen by science doesn't exist. Science is a tool to evaluate things. But if you ask the wrong question, well, you're going to evaluate things in a wrong manner. And so the thing that is important in our century, in our new scientific revolution, is that instead of having that view of the world, that superior view of the world, that vertical view of the world, science and scientists understand that they are a part of the solution. They are not the solution. There is no scientific truth that does not allow you to get what reality is. And if you focus only on science to find your answers, you're going to miss a lot of things, and you're not going to allow evolution to occur, because maybe the new evolution is cultural, poetical, is literary. You don't know what is going to be the next step that humanity is going to consider as good. You don't know that. But if you focus yourself on, well, the only valid data is science, you're going to miss all of that, because there's plenty of other ways to deal with reality and to be humans, as we saw. And science is only a tool. And okay, it's a super good tool when you're trying to predict the trajectory of Mars around the solar system. I'm not saying that's the perfect tool. When you're trying to address complex problems as psychiatric problems or things like that, that's a part of the solution, but that's not the main tool, and a lot of other tools that have to be used alongside with it. And if you deny that, well, you're going to lose efficiency. So it's important to still be able to question the scientific data and to know that it's deeply subjective. And that is not something that is easy to do, because our society justifies itself a lot through science and gains a lot of its power through science. as a doctor, I get my authority of my knowledge. So if I admit that I don't know, I lose of that authority. In the same way, our society, the social contract that you pass with the society, is that, okay, I'm going to work for you, I'm going to pay my taxes and shit, but you're going to make science and you're going to find solution and you're going to allow me to have that vision of the reality that is perfect. But if we start telling to the people, well, science is not that perfect, it does not allow to do as much thing as we promised, well, people are going to feel betrayed. They are going to be like, well, I've been paying taxes and you were supposed with that science, that beautiful method that is able to determine everything, you were supposed to find every solution to all of the problems because remember, you're able to determine everything in the universe. Universe is just billiard balls banging on each other, so why are you not able to solve all of my problems? And the thing is that because the power of science is limited, and admitting that is going through a paradigm, and going through a paradigm is a difficult thing to do. And I'm going to end on that slide and on that exercise we do with one of my friends when we're looking at the stars, is to imagine how people before, to imagine the sky before, a long time before, they imagined the sky as something, a veil that is pierced with holes and a light outside, or a painted ceiling. And then the sky became something that's flat. And you have to imagine that when in ancient times people were describing the sky as flat, well, everything was going well together. The professor was like, yeah, the sky is flat, and he was explaining everything in a manner that made sense. And people who were living in a place where they were explained that the sky was flat, well, they lived their life and things made sense, and they were not questioning that belief, and everything was making sense. And you have to imagine what the intensity of the cognitive dissonance you create when you tell them, oh, the sky is not flat, the sky is round. Flat. It's not the thing you imagine. And so that's, I think, the work we have to do, and that's the work of that intensity to question the data we have, the way we do science with that intensity, and to be able to realize that there are flows that are deep, that are important, that we have to address, and we don't have to stay in that illusion that science is able to produce perfect knowledge that is the absolute truth. Questions?
What do you think about like Foucault and like his idea that like basically we have these turning points in science, such as Einstein's theory of relativity, we have quantum mechanics, that totally upends all of our scientific models and forces us to reconsider a variety of things. And like Foucault goes over this and he says this has happened numerous times. He cites Copernicus, for example. Like, how does his ideas play into kind of your thinking?
Well, I think that's the thing I explained about the sky becoming flat to becoming round, is that you have to, these ideas completely put in question your vision of the reality. They completely shift the way you see the world. And so that needs an incredibly open mind to get these ideas to pass. And these are hard ideas to pass because by definition they put in question the way you experience the world. So I think, yes, of course, these shifts exist, these shifts are hard, and that these shifts are only enabled by the open-mindedness of people and their ability to question things that seem completely normal. You see, like sky being round, for example. I'm not saying that we're going to question that anytime soon, but that's the intensity of questioning it needs to go through these paradigms.
It seems that religion filled a function to explain the unexplainable. Now that science is becoming, well, science is doing a better job of explaining the unexplainable, there's less and less religious people. So there's less, especially in the millennial generation, people aren't going to church anymore. You see a time in the future where there won't be religion.
So, I think religion and science are two, in fact, different things, and that science can never answer the questions of religion, because if you ask science, where do I come from, who am I, and where I'm going, well, science is powerless to answer these questions for real. It can give you clues, as you've seen, of course. It can tell you, well, you evolved from that part, and it's predictable that your society is going to take that way. But it's not a question that it can really address, because it's questions that don't have a yes or no answer. It's questions that are way too complex to be addressed by science. So religion, I think, will always, spirituality, will always have its function to answer these questions that are unanswerable, and for which you have to find an answer that is acceptable. And in a way, when religion tries to answer these questions and tries to tell us where we come from and all these things, they are kind of answering religious matters. So I don't think they are opposite things, they are complementary things, and science can give you clues on what these answers might be, but there is no definite answer. And because of that, because there is no definite answer and the real answer is I don't know, you're always going to be to have an ideological corpus that tells you, well, that's fine, we don't know, but there's that solution that you can rely on to carry on and live your life.
So, just a quick question. So, it sounds like I'm particularly interested in your point earlier. You mentioned in complex systems like psychology, you mentioned science isn't the only method that you think can give us like